A new fast radio burst FRB signal has buzzed nearly 2,000 times in just 2 months, and it's raising a mystery. We have detected a strange new signal from across the chasm of space and time. A repeating fast radio burst, FRB, the source detected last year, was recorded spitting out a whopping 1,863 bursts over 82 hours, amid a total of 91 hours of observation. This hyperactive behavior has allowed scientists to characterize not just the galaxy that hosts the source and its distance from us, but also what the source is. The object named FRB 2020-1124A was detected with the 500-meter aperture spherical radio telescope, FAST telescope in China, and described in a new paper led by astronomer Heng Chu of Peking University in China. So far, most evidence points to a magnetar neutron star with extraordinary strong magnetic fields as a source of FRB emissions like this. If FRB 2020-1124A is indeed from one of these wild cosmic beasts, it's looking like an unusual specimen. Astrophysicist Bing Zhang of University of Nevada, Las Vegas, says these observations brought us back to the drawing board. It's clear that fast radio bursts are more mysterious than what we have imagined. More multi-wavelength observational campaigns are needed to further unveil the nature of these objects. Fast radio bursts have been a source of puzzlement for astronomers since they were first discovered just 15 years ago. In archival data dating back to 2001, a spike of incredible powerful radio emission lasted just a blink of an eye of time, and since then many more have been detected. Millisecond durations bursts of radio waves discharging in that moment as much power as 500 million suns. Most on record have erupted just once, making them challenging to study, let alone understand. A scant handful have been detected repeating, which has helped scientists at least trace them to host galaxies. Then in 2020, a breakthrough. For the first time, a radio burst was detected within the Milky Way, our galaxy that is, leading astrophysicists to trace the phenomenon to a magnetar activity. This most recent extraordinary FRB example is another example of a rare repeater. In less than 2 months of observation, FRB 2020-1124A has given astronomers the biggest sample of fast radio burst data with polarization than any other FRB source. Polarization refers to the orientation of light waves in three-dimensional space. By examining how much that orientation has changed since the light departed its source, scientists can understand the environment through which it's passed. Strong polarization suggests a powerful magnetic environment. Based on the wealth of data delivered by FRB 2020-1124A, astronomers were able to infer that the source is a magnetar. But there was something strange. The way the polarization changed over time suggested that the strength of the magnetic field and density of particles around the magnetar were fluctuating. Zhang explains, I equated to the filming of a movie of the surroundings of FRB source, and our film revealed a complex, dynamically evolving, magnetized environment that was never imagined before. Such an environment is not straightforwardly expected for an isolated magnetar. Something else might be in the vicinity of the FRB engine, possibly a binary companion. That companion, the data suggests, could be a hot blue B-type star, which are often found in companions with neutron stars. The evidence for this was laid out in a separate paper, led by astronomer Feiying Wang of Nanjing University in China. But there was something else peculiar too. As a type of neutron star, magnetars are the collapsed cores of massive stars that, having run out of fuel to burn and provide outward pressure, collapse under their own gravity. Such stars burn through their fuel quickly and have short lives, expelling their outer material as a supernova as the core collapses. Because their lives are so brief, these young magnetars are thought to be found in regions where star formation is still occurring. Stars live their short lives and die, creating more clouds of material to give birth to more stars. It's a beautiful cosmic circle of life. But FRB 2020-1124a was found in a galaxy a lot like the Milky Way. There's not a lot of star formations going on on here at home, so there should not be a baby boom of stars near our unusual new FRB friend either. FRB 2020-1124a is not the only FRB source to be found in the galaxy relatively devoid of star formation, though. The growing count suggests that there's some vital piece of information we may be missing, some hole in our understanding of FRB magnetars, how they form, and the locations in which they reside. By the characterization of the source means we have a new place to look for answers. The work of Wang and his colleagues suggests that neutron star, B star binaries might be one of the best places to look for fast radio burst signals. The two papers were published in Nature and Nature Communications. This was by Mike McRae, Science Alert. It's on Collective Spark. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.